Hello guys, welcome back to my YouTube channel. This is Nehati from Sri Venkateswara College of Engineering. Today we are here with another video, and today's topic is triple integration and center of gravity. So without any delay, let's get into the video. The contents for today. First, we'll be learning what is triple integration. Then we'll see how to calculate volume using triple integrals. Then we'll see center of gravity, and after that, we'll learn how to find the center of gravity using triple integration, applications of triple integration in real life, then challenges in applying triple integration, and then we'll conclude the video with conclusion. So, what is triple integration? Triple integrals are the analog of double integrals for three dimensions. So they're basically like double integrals, but for three dimensions. They are the tools for adding up infinitely many infinitesimal quantities associated with the points in a three-dimensional region. So they are the tools for adding up. They add up infinitely many infinitesimal quantities. Infinitesimal quantities in the sense, in very small quantities, there will be many very small quantities. They all are added up to find the volume or center of gravity of a three-dimensional space. So it is mainly used to calculate volume and center of gravity. And we'll be seeing how to calculate it in this video. So, triple integration is used to calculate volume in 3D space. We just read that now. It involves dividing the region into infinitesimal rectangular prism and then summing up their volumes. So, while finding the volume of a 3D space, we divide it into many infinitesimal small regions, and then we find the volume of each region and then sum up all the volumes together to get the final volume. The three integrals are evaluated in the order dy, dz, dx. This is not compulsory. We can take in any order. We can take dx, dy, dz, or dz, dy, dx, and any order we can take the triple integrals. But depending on that, we have to take the limits and the various things related to that. So the outermost integral represents the bounds of x, the middle integral represents the bounds of y, and the innermost integral represents the bounds of z. This is for the integral part dy, dz, dx. So depending on what order we are taking, we are supposed to change even the bounds of x, y, z also. The importance. Triple integration is a crucial concept in calculus, physics, engineering, and many fields. So it has various applications in real life, that is in physics, engineering, calculus, etc. So calculating volume by triple integration. We'll see how to calculate volume by triple integration. Only the procedure we are seeing now. We're not solving any sum in this video. So the first thing, okay, first let us assume we have a region R defined by its boundary and constraints. So we have a region and it's given the variable R. Okay, so set up the integral limits. First, we are going to set up the integral limits. What is setting up integral limits? Determine the limits of integration for each variable x, y, z based on the constraints of the region R. This involves finding the ranges of values that each variable can take within the region. So the limits, we are supposed to set up limits. And how will we set up limits? Is we'll be taking ranges of values that each variable can take. And which are the variables taken here are x, y, and z. So the next step is set up the triple integral. The volume V of the region R can be calculated as a triple integral. That is, V is equal to triple integration of R into dV. So dV here is infinitesimal volume. V is the total volume and dV is the infinitesimal volume element. The limits of integration should be set according to the ranges found in the first step. So in the first step, we are taking the limits. So the limits of integration will be taken according to the ranges we saw in the previous step. Choose the order of integration. Okay, the order of integration in which they integrate the variables can affect the complexity of the calculation. There's no fixed order that works for all cases, but typically you choose the order that simplifies the integral expression. Common choices are integrating with respect to x, y, z, or y, x, z. So in the previous slide, we just discussed that we can take the order in, we can take the variables in any order. So here also we're just saying that. The next step is evaluate the integral. Integrate the expression with respect to each variable in the chosen order. So we're taking in a particular order and we have to integrate that expression with respect to each variable in the order. Okay, according to the order, we have to integrate each variable. This involves substituting the limits of integration and performing the integration. So we'll be substituting the limits of integration and performing the integration. The next step is simplify and sum up. After integrating with respect to all three variables, simplify the resulting expression as much as possible. So we'll get the result. We have to keep simplifying it as much as possible. This might involve algebraic manipulations and possibly recognizing patterns. Once you have the final expression, calculate the numeric value. Okay, so the last step is interpret the result. The final result of the triple integral will give you the volume of the region R. Make sure the units are consistent with the units used in defining the constraints of the region. Okay, so the final result of the triple integral will give you the volume. So we have found the infinitesimal volume dV using all the steps. Then the final result will give you the volume of the region R. Okay, make sure the units are consistent with the units used in defining the constraints of the region. Okay, so this is how we find the volume using triple integration. So coming to center of gravity, what is center of gravity? Center of gravity is a theoretical point in the body where the body's total weight is thought to be concentrated. So where we assume the total weight of a body is concentrated, that is known as center of gravity. It predicts the behavior of a moving body when acted on by gravity. Okay, so it predicts the behavior of a moving body when acted on gravity. It is useful in designing static structures such as buildings and bridges. So it is crucial point in designing static structures such as buildings. In designing buildings and bridges, we need to know the center of gravity. Center of gravity plays a very important role. Okay, now we'll be learning how to calculate center of gravity using triple integration. The first step is set up the integral limits. Like how we did in the volume, we're going to set up the integral limits first. Just like in the case of finding volume, you need to determine the limits of integration for each variable x, y, z based on the boundaries and constraints of the object. So the same thing what we did in the volume, we'll be doing that here as a first step. Define the density function. Assign a density function rho of x, y, z that describes how the mass is distributed throughout the object. This function gives the mass per unit volume. That is nothing but density at each point within the object. So rho of x, y, z gives the density at each point within the object. Next step is set up the triple integral for center of gravity. The coordinates of the center of gravity, x, cg. Cg is nothing but center of gravity. So x, cg is x of center of gravity. Y, cg, z, cg can be calculated as triple integrals using the expression x, cg is equals to 1 by m triple integration of x into rho of x, y, z into dv. Then similarly, y, cg is equals to 1 by m triple integration of y into rho of x, y, z into dv, and z, cg is equals to 1 by m triple integration of z into rho of x, y, z into dv. Here m is the total mass. So m is taken as the total mass of the object, and dv, like how we saw in the previous step, it's like the infinitesimal volume element. Okay. So the next step is evaluate the integrals. So the step after setting up the integrals will be evaluating it. Integrate the expression for x, cg, y, cg, and z, cg using the limits of integration and the density function defined in the previous step. So in the previous step, we took what is xcg, ycg, and zcg. So here we'll be integrating the expressions using the limits. Okay, last step is calculate the center of gravity. Once you have the numerical value, so after calculating xcg, ycg, and zcg, we can use these coordinates to describe the center of gravity in the object's coordinate system. Okay, so one note we have to remember here, and even for the volume, is that the complexity of triple integrals involved in finding the center of gravity or even the volume depends on the shape of the object, density. Here, even density will take, but in for volume, even it depends on the shape of the object. In some cases, symmetry properties can simplify the calculation significantly. Okay. So, what are the applications of triple integration in real life? Will be saying so first is fluid dynamics, the architectural design, astronomy, and astrophysics. There are many more, but these are the few important ones I've taken here. So, fluid dynamics, triple integration can be used to calculate the volume and mass flow rates of fluids in pipes. Okay. So triple integration can be used to calculate the volume and mass flow rate of fluids in pipes, tanks, and other containers. It's essential to design efficient fluid system. So in fluid dynamics, triple integration is used. The next one is architectural design. Helps architects and engineers determine the optimal size, shape of structure, such as buildings, bridges, and tunnels. It ensures structural stability and safety. So the last one is astronomy and astrophysics. It helps scientists calculate the volume and mass of celestial bodies such as planets, stars, galaxies. It's crucial in understanding the cosmos and its evolution. So triple integration is not just something we study. Simply, it's something that is applicable even in real life, and that too in many various fields. Okay. So next one is challenges in applying triple integration. We usually find it difficult to apply triple integration, and we'll just see what are the challenges we face in applying triple integration. Complexity. The first one is complexity. Calculating triple integrals can be challenging, especially for complex regions. It requires a solid grasp of calculus and 3D geometry. So we may find it complex because uh, it is a bit difficult, but if we have proper knowledge of calculus and 3D geometry, it becomes easy for us to study. The next one is integration limits. Determine the integration limits can be tricky, especially for non-standard shapes and asymmetrical regions. Sometimes taking the limits for a particular integral can be a bit tricky, especially for non-standard shapes and asymmetrical regions. The last one is numerical approximation. Approximating triple integrals numerically can be time consuming and computationally demanding, especially for large databases. So these are the challenges of applying triple integration. And finally, coming to the conclusion, triple integration is therefore a fundamental concept in mathematics, and it has far-reaching applications in engineering, physics, finance, and many other fields. Understanding it can empower us to solve many complex problems and design innovative solutions. When we keep studying this, we may feel that it might not be useful, but then it is very, very useful topic. It is used in many fields, and that too in many important fields it is used. So triple integration is one of the fundamental concepts in mathematics. Okay, and it's widely used in engineering, physics, finance, astronomy, astrophysics. So we don't have to underestimate triple integration. It's very important subject. It's a very important topic, and if we have a proper knowledge of calculus and 3D geometry, it becomes even more easy. So that's all for today. Thank you for watching my video, and please do like it, share it, subscribe to my channel without pay. Okay, so that's it for the video. Thank you everyone for watching it. Thank you.